So now that we've added, two new tools to our toolbox for multiplicity, for thinking about how the root behaves as it gets to the x-axis, and end behavior, right, that tells us how the graph behaves kind of out of the edges. Okay, let's see how we can put these things together, and use this to get a quick sketch of some specific polynomials like this guy here. Okay, so the first thing I want to think about, I think it is generally easier if you talk about the end behavior first. Right, so what is the end behavior of this going to look like? Well, remember, all I care about is the leading coefficient of this thing after I multiply it out. And the leading coefficient is going to be determined by multiplying this by this by this by this. It's the first term of every factor, and we have to include any constants that might be out in front. So if I multiply all of these out, this is going to become 2x to the third. Now remember what we do from here. If you like memorizing rules, you probably got this memorized. The way I think about this is, it's just if I put a really enormous number in there, what's going to happen? All right, so if I put 1,000,000 in here for x, I get 1,000,000 cubed. That's a positive number. And I'm going to multiply that by positive 2. That's also a positive number. So really big x values are going to give me really big y values. So the function is going off like this. It's increasing to the right as x gets big. Now, do it again with a negative number. If I put negative 10,000,000 in there, negative 10,000,000 to the third is a really big negative number. You multiply that by positive 2, it's still a really big negative number. Right? So that's telling me that as the x values get really negative, way out to the left side, the negative x-axis, the y values are also becoming negative. So it's going to drop to the left. Okay, good. That's the end behavior. Right? Now we know what's going on at the edges of the graph. Now let's go back and think about what's going on in the middle. Okay, well, I get 3 roots here. I get x equals 1 from this one, and I get x equals negative 1 from this one, and x equals 4 from that one. So what's that telling me, right? I like to put things in the graph as I go along, right? So I know x equals 1 is a root, and x equals negative 1, and x equals 4. Okay, so now what we need to think about is what happens at those roots. All right, so I've got the roots. I like tables, right? I like to organize things. So here I've got my roots. Underneath that, let's think about the multiplicities. Well, the exponents for all of these factors are 1. So the multiplicities are all 1. And now we can talk about the behavior. Remember our rule, if the multiplicity is even, it touches the axis. And if it's odd, it goes through it. All right, well, these are all odd, so I'm just going to put through kind of down here and let it span the whole thing, right? Because all of them are the same. Now, one other point I also like to grab, just because it's usually really easy to get it, I also like to get the y-axis. You remember, to find the y-axis, we just set x equal to 0. P of 0 is 2, 0 minus 1, 0 plus 1, 0 minus 4. So what do I have? 2 times negative 1 is negative 2, times 1 is still negative 2, times negative 4 is 8. So the y-axis, the y-intercept, wow, is way up there. It's way up here. Right, so this graph is like seriously jumping around. Okay, so now I know enough to sketch it. I have to start way down here and go up. So I'm going to come up. I'm going to pass through this root. I'm going to go flying up here to that y-axis. I'm going to go down. I'm going to go through this one. Then I have to turn around, come back to this one. Truth be told, if you pick a test point in there, calculate like P of 2, for example. It's probably going down quite a bit further than that. Right? But remember, we're just sketching here. So that's accurate enough. right? That's my quick sketch of this graph. Okay. Okay, so take a look at this one. Why don't you pause the presentation, try doing this on your own, right? Work through the multiplicity, the end behavior, see if you can sketch a quick graph. Start it up again, we'll go over it together. All right, so remember the end behavior, it depends on the x's, the x term in each factor. So I'm going to start with the 3. I'm going to get negative x to the third from the first factor, x to the fourth from the second, 2x squared from the third. All right, so let's multiply these out then. This becomes 3 times negative x to the third times x to the fourth times 4x squared. All right, so there's the numbers. 3 times negative 1 is negative 3 times 4 is negative 12. And what are my exponents? 3 plus 4 plus 2, x to the 9th. Okay, so again, right, you know how I like to reason through these. Put a really big positive number in there for x. I'm the way out on the far right side of the x-axis. And you're going to get negative 12 times a really big positive number, which is a really big negative number. So as the x numbers go way out to the right, the y numbers become negative. So it's decreasing to the right. Okay, and I kind of work the same argument. Put a really big negative number in there. A really big negative number to the 9th power is a really big negative number. Multiply that by 12, by negative 12, and you get a really big positive number. So as the x numbers go way out to the left side of the x-axis, the y numbers are getting really big and positive. So it's increasing to the left. All right, so there's my end behavior. Awesome. Now let's think about roots. All right, there's 3 of them here. I get x equals 2 from this one, x equals negative 1 from this one, and x equals 5 halves, which is 2.5 from this one. Okay, now that 2 and the 2.5 are really close to each other, and I like to try to spread things out on the graph just because it makes it easier to read. So what I'm going to do, I'm going to count each of these grid lines as being 1/2. Okay, so this will be 1/2. This will be 1, 1.5, 2, 2.5, and so on. Right, so that's still going to leave them pretty close together, but we'll see what we can do. All right, so x equals 2 is going to be here. 2.5 is here, and negative 1 is going to be here. All right, so let's talk about multiplicities. This one, the exponent is 3. Here it's 4, and here it's 2. So what does this tell me about the behaviors? That means it crosses or goes through here, and it touches, kind of a bouncy looking effect, touches at these 2. Right, and that's enough to graph it, right? Just keep really careful track. Okay, so it has to start off up high, upper third quadrant. It's going to come down to this root. That one is this negative 1. So it's going to touch there. It's going to come back up. It's going to turn back down, and it's going to cross at, oh, make sure I get them right. Nope. Yeah, sorry, it crosses at 2, turns around, touches at 2.5, turns around, and dives back down. There you go. There's your graph. Okay, let's try one more. This one is a little unusual. All right, it's a little different. Okay, so first, let's think about end behavior. Right, I've got an x here and an x squared here. That gives me x to the third. And you can do our test, right? A really big positive number becomes positive, so it's increasing here. A really big negative number is negative, so it's decreasing here. Okay, now let's talk about roots. Here's the part where it gets a little different. I get a root here that's 1, right? And then what happens here? I don't get a root from this one. That doesn't factor. And remember, when we're talking about graphing, not doing imaginary numbers, right? Not doing imaginary numbers at all. Okay, so what are my multiplicities? Well, the multiplicity here is 1, which means the behavior is crosses. All right, so my root is here, right? At 1. Okay, so what's this going to look like? Well, here's where our method is going to fall down a little bit on us. I want to say it comes up like this and cuts through here and then goes up here. Maybe. See, there is another option. Another option is it could come up and go like this, right? It could bounce around in there. I don't know which, right? My tools don't answer this yet. To answer that question, we're going to need more information, right? We're going to need better tools. Not better tools. I shouldn't make a judgment call there. We're going to need more tools, right? Tools that give us different pieces of information. So, what's coming up next? More tools, right? And the big tool we're going to talk about coming up next here. And actually, let me. Well, I can't go back. You notice these polynomials, frankly, they weren't very realistic. Okay, I mean, just being honest about it. Usually, when we get polynomials, they're not already nicely factored for us, right? Like these all were. So what we're going to look at in the next several lectures is additional tools, additional theorems, techniques for coming up with the factorization of a polynomial. Once we've got that factorization, then we'll be in a position to bring these tools back out, and then we'll see what our graphs look like.